Good morning to lecturers, and this is the MATLAB video where I explain what each line represents. First of all, we have clear CLC close all is to repeat the uh, coding. Second of all, we have K, C, and M equivalent value. This is where the constant are given in this question. Mass equivalent value is the mass of all this beam, this, and also this beam, and 5 industrial machine will calculate it into this point I, and all mass are constant for all ideas. For this line, 9 until 35, there are 5 setup and 1 original setup. Sorry, 5 idea and 1 original setup. A is the value of from our rotation point until damping system. So in this arrays, there are 0.6 for A to B. For B is a hypotenuse from I until A. 0.6 times 0.6 times 6 square plus 0.6 times 2 square root is the value 3.794. It's also same for every damper on B, on F, on K, and also on P. For idea 1, also same according to the value. This is the value from damper to point of rotation, and this is the value of I to point of rotation, taking the point as hypotenuse. In this coding 35, 36 until 67, we taking MEQ as constant, so for all ideas MEQ is the same. KEQ is summation of K times A square over B square. The reason for idea 1, 3, and 5 have this 1.6667 is in that idea we have spring or damper located on O point. So to ease my job, I calculate this only region and put it as one single value for each ideas. In result or summary table, we use setup original idea 1 until idea 5, where each represent its own category. For calculation for omega n natural frequency and zeta damping ratio, we use formula omega n equal to square root k over m. For calculation of damping ratio, we use formula C over 2 square root km. And then this is the final output, and this is graph that shows our damping ratio versus setup and natural frequency versus setup. So I'm going to run this code. Okay. These are the value. These are the graph for each ideas, where the highest point represent the natural frequency, and on this bottom highest point represent damping ratio. For and then for table we have These are the table for M equivalent, K equivalent, C equivalent, omega n for each setup, and damping ratio for each setup. That's all from me. Thank you.